You shouldn't say that 5 times fast. All right. Now, I will say they have a section 3, solving more difficult systems by substitution. And I actually skipped that section altogether because solving by elimination, which is the third way to solve, is easier when it's a more difficult system. So I wouldn't solve it by substitution if it was a more difficult system. I would actually solve it the third way. If it's a simple one like the ones we're going to do today, I would solve by substitution. It's really easy to do it. Okay? The whole point of substitution is to substitute. All right? So it's the graphing method of solving works well if the coordinates of the solutions are small integers. By integers, I mean positive and negative numbers, whole numbers and their opposites, okay? But if it crosses in between two numbers, then you're kind of playing a guessing game as to what your answer is, right? All of the ones we've been doing have crossed nice and pretty on the crosshairs, all right? And that's nice. That's when you would want to graph them. However, there are times when you get a fraction as your answer or you get something that's not as easy to do. And so substitution is a little bit simpler than graphing. All right, the substitution can be used to find a single variable. So you find either your x or your y first, and then you go back and plug it into one of your original equations to solve for your other variable. All right, so let's look at the first example. Solve the system by substitution. Example 1 on page 284. Now what you'll notice about this is you have x plus y equals 5, and then you have y equals negative 3x plus 7. You'll notice that in one of the equations, the variable is already by itself. This is often one that you're going to say, this is a good one to solve by substitution. You see that y is all by itself. And so what we're going to do is we are going to see, can we have a variable in one of the equations completely by itself? And the answer here is yes, we already have it. All right, so you can see that we already have this y all by itself. So what we're going to do for substitution is we are going to take that answer, like what the y equals, and we are going to plug it into the other equation instead of that variable. We are going to substitute. Think about anyone who plays a sport, what substitution means in the sport. Person comes in, takes the place of the person that's going out, right? And they will take that position as well, okay? You're not going to substitute in football your quarterback for one of your receivers, right? You probably want to replace a second string quarterback for the quarterback position, right? Because that's what he's trained for. And so it is exactly where it is in the other function, okay? So what we're going to do is we're going to take my function that does not have the variable by itself, and we are going to rewrite it. We're going to say x plus, and instead of this y, we are going to substitute what the other y equals in the other equation. So we're going to substitute this whole entire thing in for y, all right? So instead of y, we're going to write negative 3x plus 7. So in our original equation, it was x plus y equals 5. Now we're going to say x plus what the y equals and just equals 5. We're just substituting in the variable for what the variable equals in the other equation. We are substituting it in. Now you'll notice that we have an equation with one variable, and we know how to solve equations with one variable. It's just solving equations like we've been doing since the beginning of the year. Because this is plus, those parentheses are okay to just remove because there's just a positive 1 in front of the parentheses. So if we distribute a positive 1, it doesn't change anything. So we can just rewrite this x plus negative 3x plus 7 equals 5. If there had been 3y or minus y, we would have to worry about distribution, okay? But there's a positive 1. The parentheses can just go away. What are my like terms here on this left side of the graph, or the equation? What's my like terms? X and negative 3x. What is 1x and negative 3x? How many x's do I have? Negative 2x plus 7. What do I need to solve now? I need to move what over? The 7. If I move it to the other side, it's going to change signs. It is a plus 7. It needs to be a minus 7. I have moved it so it is away from this side. I just have a negative 2x left here. Make sure you bring down your equal sign. What's 5 minus 7? You start with 5, you give away 7, you have -2. What's my last step here? Divide. I need to divide both sides by the -2. -2. So on the left-hand side, my -2's cancel. What is -2 divided by -2? +1. Now, when we were solving by graphing, what did our answer look like? A coordinate pair. What do I have here? An X. So I do not have a Y. Every single answer has to have an XY. It is a coordinate. You are answering the same question, just a different way. If I had said solve by graphing, you would have graphed these two and you would have gotten an XY. So when you solve by substitution, your answer should be an XY. If I have an X to get a Y, I just plug in my X, all right? You can go back to either equation. It doesn't matter which, you should get the same answer. So if I go back to this X plus Y equals 5, and I plug in my X, I would just say 1 plus Y equals 5. Subtract my 1, Y is going to equal 4, right? If I go back to the other one, Y equals -3X plus 7, and I plug in a 1 for my 3, Y equals -3 times 1 plus 7, which is -3 plus 7, my Y will equal 4. So it does not matter which equation you go back to. Pick the easiest one to plug it in. You will get your other variable. So then your answer needs to be exactly like it would have been had you graphed it. Your answer is going to be X, Y, in that order, because it is a coordinate. You're telling me where they cross. All right, you will notice that none of the variables are solved. So that means there is no variable completely by itself. So what you want to do is you want to get a variable completely by itself. Now, it does not matter which variable you choose. Choose the variable that is the easiest. We're going to do another example on the next page that's even more obvious. Honestly, x, y, either one of those is easy to get by itself in either equation. I will say if you were to move one of them on the top equation, then you're going to have to deal with negatives a little bit more. Okay? And because you're going to create a negative when you move it over. On the second equation, you have a -y. And you can make him a positive by scooching him over to the other side. Does everybody see that? And so in my mind, I would take the second equation and get a variable by itself. But you are just looking at these equations and say, which of these variables can I get by itself, okay? And so I am actually going to choose this second equation. I'm going to take this guy right here, and I'm going to get my x all by itself, okay? How do I do that? Well, I'm going to take my x minus y equals 10, and what I'm going to do is I'm going to move my y over, okay? I am choosing to do that because I know I'm going to be less work with negatives if I do that. So if I do that and move that y over, it becomes a positive y plus 10. Everybody see that? So I took my second equation and I made a variable by itself by moving everything else over, okay? Now that I have done that, I am going to take my first equation, so whichever equation you did not change, go back to that one. So I'm going to take the x plus y equals negative 4. That's the one I have not worked with yet. All right? And I am going to take this thing right here that I just solved for, and where am I going to put it? I have to substitute it in. I have to substitute it in for what it equals. What does it equal? X. So I'm going to take it and I am going to write it instead of my x. All right? So I have x plus y equals negative 4. I'm going to rewrite this and replace my x with this right here. Okay? So instead of x plus y, I'm going to write y plus 10. I'm just replacing that x plus y equals negative 4. I'm just substituting it in. Okay? So when you do not have a variable already solved, you're going to find the easiest one to get by itself in either equation. Once you get it by itself, you are going to now substitute it into the other equation, the one you have not solved yet, okay? And now you'll see I have an equation with only one variable, a y. That's my whole goal here, is to get only one variable so I can solve. What are my like terms over here? My y. So I have y and y. How many y's do I have? I have 2 y's. I have a plus 10. What do I need to do? Yeah, move the 10 over, right? Because it's going to the other side. It's left this side. It changes signs over here. Negative 4 and negative 10 is negative 14. What's my last step here? Divide by 2. Y equals. Am I done? No. Remember, my answer is always an xy. Okay? All I have is a y here. What do I need? X. An x. So take either equation. I'm going to just use this guy right here. X plus, I already know y. What is y? Negative 7 equals negative 4, right? What do I need to do here? Yeah, move him over. He's going to leave here. He's going to change to a positive over here. X equals 3. So my final answer here is my x, y. All right. Questions on that? Solve either equation for either variable. Choose the easiest variable to solve for. Substitute the solution into the other equation to obtain an equation in one variable, and then solve. Solve that new equation. Use the value of your new variable that you just solved for to solve for the other variable, and then write your solution as an ordered pair. For all of these, you can check them by plugging them back in. You want to plug them back into both equations and make sure you get a true statement. And we're going to do that on this example. All right? This says solve by substitution. Let's look at these variables. I'm going to start down here. Is this an easier variable to get by itself? Why or why not? Probably not, because there's a 3 in front of it. And if I divide everything by 3, I am going to get fractions. How many of you want to do substitution with fractions? Okay, I'm just saying. All right. What about this guy? Is he easy to get by himself? Once again, if you get him by himself, you will have fractions, all right? This guy, you won't have a fraction here necessarily, but he has a negative 4 in front of him. The easiest one to get by itself is this one, He's already kind of by himself. He doesn't have a coefficient. That is what I'm going to look for when I'm trying to figure out which variable to solve for. What is the easiest one to get by itself that requires the least amount of stuff for me and will not create more work by creating something like a fraction? Okay? So that's the one I'm going to use. And I am going to take that equation, x minus 4y equals 0, and I am going to get the x by itself. How do I do that? Move the y over, right? So I'm going to move this over here. On this side of the equation, it's going to cancel out. It moved across the equal sign. So what happens to my negative 4y? It becomes a positive 4y. Technically, a positive 4y plus 0. What is anything plus 0? Itself, right? So it is just positive 4y. So now I have gotten a variable completely by itself. I am now going to use my second equation, all right? My second equation was 3x plus 2y equals 8. All right, I have the x by itself. So what do I need to do with this? Where does it go over here? It goes for the x. So I'm going to take him and I am going to replace this equation for that variable. Substitute. So I'm going to rewrite that equation 3, and instead of x, I'm going to write what? 4y plus 2y equals 8. All right, so 3 times 4 times y is what? 12y, right? Plus 2y equals 8. And they still gave it. You can always multiply, yes. You just can't add unless they're like terms. So these are like terms for adding, right? So 12y and 2y, how many do I have? 14y's equals 8. What's my last step to solve for my y? All right. It is not perfect, but we can reduce it. What goes into 8 and into 14?
4 sevens.
Yeah, it's divided by 2. So 8 divided by 2 is 4. 14 divided by 2 is 7. So I have a y equals 4 sevenths. 4 sevenths. All right. Which means that I need to solve for my x. All right. So I'm actually going to go back to my first equation to do this. All right. X minus 4 times y equals 0. Remember, when you are multiplying fractions, it's just whole number over 1 times the fraction, multiply across. What's 4 times 4? 16. 1 times 7 equals 0. I haven't solved yet. I need to move it over, right? So I need to move this over, but I'm adding to 0. They were very nice. X equals, it was negative 16 sevenths. I moved it across the equal sign, so it is positive 16 sevenths. All right? And that's actually my answer. My x value, my y value. That is my answer there. Very true. I don't know about the whole comic strip thing there, but the truth is that you can make it so much more difficult for yourself if you don't pay attention to which one is the easiest one to solve for, honestly, okay? So look for the easiest one to solve for. And your answer should always be an XY. Do not stop at the one variable or you have not finished the problem. You've only answered part of it, okay? All right, Brian has 84 feet of fencing and wishes to fence a rectangular area so that the length is 6 feet longer than the width. Find the dimensions. If you are using fencing, what are you talking about? Area or perimeter? Perimeter. Okay, so the perimeter of a rectangle is 2L plus 2W. You should know this. We've already done this equation this year. If he has 84 feet of fencing, that is the length of his perimeter. Okay? So the first equation that we know is that 2L plus 2W is going to equal the 84 feet of fencing that he has. Okay? The other equation is actually given to us. It says the length is 6 feet longer than the width. Length, that is my L, is, what does that represent in an equation? Equals. How would I write 6 longer than the width in variables? 6 feet longer. What am I going to write? W plus, yeah, 6 plus W or W plus 6, yes. Take the width, they want 6 more feet, okay? 6 more feet. They already have a variable by itself, do they not? Yes. So I can go straight to my substitution. I can take this group and I can replace it in this equation for L. 2, instead of L, I'm going to write that group, W plus 6 plus 2W equals 84. I am going to distribute 2W plus 12 plus 2W equals 84. Combine your like terms. 4W plus 12. Subtract my 12, right? And then divide by 4. All right, I have one of my dimensions, W. It is 18 feet. If my length is 6 foot longer, I just plug it in. How long is my length? 24, so it's 18 feet by 24 feet. And I am done with that one.